Chapter 15 begins on page 361 in your math book. This week we're going to be discussing simple dilutions, mixtures, and compounding. So a lot of very vital math concepts this week when it comes to working in a compounding pharmacy. If you're ever developing formulas for medications or verifying that the ingredients that you need are correct, this math can definitely assist you in those aspects. We also use these calculations a lot when we do the compounding competition in the institutional quarter as well. So starting out, every solution has what we call a solute and a solvent. So a solute is usually the powdered portion of the drug. It could also be a more concentrated liquid. But regardless, usually the solute has our active ingredient in it. So that is going to be our drug that is being dissolved. And then we're going to dilute that down with what we call a solvent or a diluent. So that is the substance that we use to dilute the solute. A lot of medications will come in a higher concentration than we may necessarily need. So the first concept that we're going to talk about today is just simple dilution. So taking one strength and then adding a solvent to that original strength and diluting it down to make a less concentrated solution. So we're going to go through simple dilution, like I said, in this lecture, and then I will cover these alligation methods a little bit later here. So once again, simple dilution, we're just taking one concentration, diluting it down with a solvent to produce a new concentration and a new volume. So there's some rules that we have to follow. These rules will stick with us as we go into those alligation methods as well. So number one, convert all amounts to metric measurements before we start any calculations. So if something is in household or apothecary, make sure we convert that over to metric first, because that will make our lives a lot easier. Number two, the units of strength and or volume or weight must be the same within the calculation. So for example, we cannot be comparing milligrams to grams. You would have to convert one to the other so that those would be in the same unit. And then number three, when ratio strengths are given, always convert to percentage strengths. So this is where chapter 14 plays a role in this week's math. I told you last week that it would follow us over, and that will be occurring in a few problems this week here. So anytime you're given a ratio strength, you got to convert that into a percentage strength first. If you're still struggling with that concept, I would go back and watch the lecture from last week. And then if you still have questions, get with me on that and let me know so we can make sure that you're comfortable with that concept before moving on to this week's math. On your lecture worksheet for this week, I have also written two of these rules at the top. So convert all ratios to percents, convert all amounts to metric. If you want to make a note on there of this second rule here, make sure your units are always the same as well so that you do not forget that. Okay, so simple dilution. Like I said, we're just going to be diluting a higher concentrated solution with a solvent to reduce the strength. So keep in mind, the amount of active ingredient will remain the same. It's just going to be diluted based on how much solvent that we add to that, okay? So let's take a look at this first example here on the slides. So you have a 200 ml bottle of 5% medication A. you're asked to prepare a 2% solution. What volume will the new solution be? Okay, so here we are given a stock quantity and a stock strength or concentration. So this is what we have in stock. So I'm going to write that down and I'll make my screen bigger here in a little bit. So in stock, we have 200 mils of a 5% solution. We want to make a 2% solution. So that is going to be what we are desiring. So I'm going to put that as my desired. We want a 2% solution. And we don't know the volume. It says, what volume will the new solution be? Okay, so we're looking for the volume. Remember, the metric unit of volume that we use is milliliters. Okay, so I'll show you what I wrote down here. In stock, we have 200 mils of a 5% solution. We're wanting to make a 2% solution, but we don't know how many mils that will be. That is what we are solving for. Okay, so this is the equation that we're going to use for simple dilution. So might look a little bit scary at first, but it's very simple, I promise. And I'm going to show you how to use this equation with this example here. So we have Q1 times C1 equals Q2 times C2. Okay, anytime you see a Q, that stands for quantity. So the quantities that we're going to look at, those are going to be units of volume. So most of the time, our quantity is going to be in milliliters. Now, anytime you see C, that stands for concentration. A concentration is the same thing as a strength. So a lot of times our concentration is going to be in a percentage strength form. So if you ever have a concentration given to you in ratio strength, you're going to have to convert that into percentage strength before you plug it into this equation, okay? So I've written that down right here. Q1 times C1 equals Q2 times C2. Now, what I always do is set one side of my equation. I'm going to label that as my stock. And then the other side, I'm going to label that as my desired. So this is what we have on hand. This is what we are trying to make. And from there, I'm just going to plug in all of the information that I have written from my problem. Okay, so my stock quantity, remember quantity is volume. So in stock, I know that there are 200 mils of this solution. So I'm going to plug that in where my Q1 goes. So 200 mils. And I'm going to take that times the concentration of my stock, which we said was a 5% solution. Percentage strength is fine. That's what we want. So we're going to leave that as 5%. And I'm going to set that equal to my desired. So they are desiring a 2% solution. We don't know how many mils. So the quantity here, we do not know. That's what we're solving for. So we're just going to keep that as our Q2. And then we're going to take that multiplied by our concentration or our strength, which is a 2% strength. Now I have just one variable that I'm solving for here. So I want to get this by itself so we can solve for Q2. So since this is Q2 times 2%, I can do the opposite of multiplication to move this 2% over to this side. So the opposite of multiplication is division. So I'm going to divide off this 2% over here, which will cancel that out over here. But whatever I do to this side, I also have to do over here. So I'm going to divide this by 2% as well. Now, when you're typing these in your calculator, there is no need to change these into decimals because they're both in percentage form. So you can just take 200 times 5, leave that in your calculator, and then we're going to take that divided by 2. So 200 times 5 gives us 1,000, and then we're going to divide that by 2, which gives us 500. So Q2 equals 500 milliliters. And that's because these percentage signs would cancel out. We would be left with mils here, which is what we were looking for. That Q2 was in milliliters, okay? So we just solved for the amount of solution that we are going to make here, okay? So we're going to make 500 mils of this solution, okay? So if I am taking 200 mils of a 5% solution, I want to make a 2% solution that is 500 mils. I'm going to be combining this stock solution with a solvent or a diluent, okay? So I want you to imagine this, okay? I'm going to have my stock solution that is 5%, and I'm also going to have a diluent, which we'll just say that that is water, okay? Your diluent doesn't have any active ingredient. So I'm going to combine these together to make a very poorly drawn bottle, a 2% solution, and we just said we're going to make 500 mils of that. So I know from my stock, I'm combining 200 mils of that stock. So if I know I'm making a total of 500 mils, well, my diluent, this has to be an amount that is the difference between these two. My 200 mils will go in here of my stock. So 500 minus 200 would give me 300 mils of my diluent. So I'll pour that in there. Then we get our 500 mils of a 2% solution, okay? So basically what I did here, you always take your total minus your stock to find the amount of diluent or solvent. So it means the same thing here. So what we did, our total volume, 500 mils, minus our stock, which was 200 mils, gave us the amount of solvent that we would be adding, okay? So we're combining these two solutions together to dilute this concentration down. You see that the concentration is getting smaller. Same amount of active ingredient in here, we're just diluting it with that water to make a lower strength with a higher volume here. Okay, so looking at this lecture worksheet here, I have the rules up top. I have the simple dilution equation that you can follow here. Remember, Q is quantity, C is concentration. Set your stock equal to your desired, okay? So let's take a look at this first example. A physician orders 325 mils of a 20% solution to be prepared from a stock supply of an 80% solution, okay? So this time we have the order. We have the ordered volume and percentage, and we have our stock concentration. So we're just going to plug this into our equation here. So remember, this side is our stock. This side is our desired. So stock. The question says, how many mils of stock are needed? Well, that is my Q1. I do not know, so I'm just going to leave that as Q1. My concentration of my stock tells me that it is 80%. So I can plug that in where my C1 goes. Then I'm going to set that equal to what is being ordered or desired. Well, it says that they're ordering 325 mils. That is my quantity. So that's my Q2 of a 20% solution. That is my concentration. Now, to get Q1 by itself here, I'm going to need to do the opposite of multiplication, which is division. So we're going to divide off the 80% here. That's going to cancel out. Whatever I do to this side, I have to do over here. So now in your calculator, remember, do your multiplication first. 325 times 20%. Leave that in your calculator. That gives me 6,500. Then I'm going to divide that by 80. That leaves me with 81.25. So Q1 is 81.25 mils. That's my quantity. Remember, your percents would cancel out here. Left with mils. So now how I know how much stock solution I need. So 81.25 mils of stock. Remember, our stock was 80%. Then it says how many mils of solvent or sterile water are needed. Okay, so going back to my equation that we just talked about, remember, you can always take your total minus your stock to solve for your solvent. I would write that up here if you have already forgotten that. So take your total minus your stock to find the amount of solvent that you need. So remember, the total volume that we were making, our desired volume, was 325. And we're going to subtract out the amount of stock, which that's what we just solved for, 81.25 mils. And the difference will give us how much solvent we would need. So 325 minus 81.25 leaves me with 243.75 mils of solvent. All right, number 2. An order is received for 15 grams of petrolatum to be combined with 45 grams of 0.25% hydrocortisone ointment. What is the strength of the final product? Okay, so let's think about what's happening here. They're combining 15 grams of petrolatum. That is basically petroleum jelly or Vaseline, okay? So that's going to be our solvent. That doesn't have any active ingredient in it. So let's just think about that. We have 15 grams of solvent, and we're combining that with 45 grams of our 0.25% hydrocortisone ointment. So it tells us we're combining those, okay? So when we put these together, that's going to give us a total of 60 grams, okay? So you really have to read these problems carefully to understand what's happening here. And it says, what is the strength of the final product, okay? So this is an example of a problem where they have given us the amount of solvent already, okay? So we're not going to have to solve for that, but this is still a simple dilution problem, okay? So let's look back at our equation here. So remember, set your stock equal to your desired. Well, what do I know about my stock here? They tell us that our stock, we have 45 grams of a 0.25% ointment, and we're going to set that equal to our desired, which we just said was our final quantity here is 60 grams. We're going to be looking for the final strength, okay? So stock Q1 would be our 45 grams. C1, our stock concentration, would be 0.25%. Set that equal to our final product, or our desired. Well, we're looking for the strength. Well, I know my quantity is 60 grams, so my Q2 would be 60 grams. And this time, I don't know the strength. I do not know my concentration. So we're looking for C2 in this case. So now let's solve for C2. Divide 60 from both sides. Once again, you do not need to convert this into a decimal. Just leave that in percentage form. That way our answer will come out to a percentage form. Okay, so 45 times 0.25 gives me 11.25. Then I'm going to divide that by 60. That leaves me with 0.1875. Remember, those grams would cancel, so this would be our percentage strength here. Now, it doesn't specify how to round this. I would probably at least round that to the nearest hundredth, so roughly 0.19%, okay? So that's the strength of this new final product here. So that one was a little bit different. They gave us the solvent, so we had to first figure out the final weight in this case, or the final quantity, before we could plug that into our equation, okay? So really make sure you read these problems carefully this week, especially on your worksheet and your book assignment. All right, number 3. Here we see a ratio strength show up, okay? So don't forget that rule. Anytime you see a ratio strength, we have to convert that into a percentage strength first, okay? So prepare 1 liter of a 1 to 15 creosol solution from a stock solution of creosol 12%, okay? So I see that ratio. I got to change this into a percentage strength first. So remember, start with what we know. We know that that means that there's 1 gram of active ingredient of creosol in every 15 mils of solution. Now to change that into a percentage strength, remember that percentage strength is always X over 100. So I'm going to set that equal to X over 100. We're basically taking 100 divided by 15, which gives us 6.67%. I just rounded that to the nearest hundredth. So I know that that is now the strength I'm going to be working with. All right. Now we notice that our question says, how many mils of stock solution are needed? But in my question, it tells us to prepare 1 liter. So right off the bat, that brings us to our other rule up here. So it is already in metric measurement, but if you wrote that third rule, it says that units must be the same. I forgot to write that up here. Units must always be the same, okay? So in this case, I can't compare liters to mils. So I got to convert this here to mils first. So 1 liter, hopefully that you know that is 1,000 mils by now. Now our problem looks a lot better. Now we can begin to plug that into our equation, okay? So remember, always set your stock equal to your desired. This time, all we know about our stock is that it's 12%. So I do not know my stock quantity. I do not know Q1, which that is what our question is asking for here. How many mils of stock solution? Well, I don't know that yet. That's what I'm solving for. Stock concentration, we know, is 12%. And then we set that equal to our desired. Well, we want to make 1,000 mils, which is our quantity, of a 6.67% solution. So then I can solve for Q1. So get Q1 by itself, divide by 12% on both sides. So 1,000 times 6.67. Leave that in your calculator and then divide that by 12. That leaves us with 555.8. I'm just going to leave it at the nearest mil, or the nearest tenth of a mil, 0.8 milliliters, because remember that's our quantity here, and those percentage signs would go away. We'd be left with mils. So we wanted 555.8 mils of stock. Now it says how many mils of solvent are needed. Well, that brings us back to this equation here. Total minus stock equals solvent. So we're preparing a total of 1,000 mils minus our stock. So 1,000 minus 555.8 gives me 444.2 mils of solvent. All right, so now we have our 2 ingredients here. Now it's asking us for directions. By directions, they just mean tell somebody how we could make this compound. Well, we know the 2 ingredients and we know what those ingredients make once they're combined. So we're just going to write this in a sentence, okay? So we're going to combine 555.8 mils of our stock, which it's very important that we indicate what the strength of our stock is. So remember, our stock was a 12% solution of 12% creosol solution. We're going to combine that with 444.2 mils of solvent. They don't specify what our solvent is, so we'll just leave it at that. To make what we're trying to prepare, to make 1,000 mils of a 6.67% creosol solution. So all we did was just write out the instructions for how to make this compound. If you're confused about that, just read through this again and verify that each one of your ingredients, you're combining those together to make what is supposed to be prepared or desired.